Okay, so I'm gonna start with question one. I sort of already did a couple other questions on the same sheet, but I will flip to the next page when I get there. So classify each of the four substances in the table as ionic or molecular. Explain how you know. So this first one for calcium acetate, we're saying that it is ionic. That's because calcium is a metal, and acetate, which is denoted by this here, is a polyatomic ion. So we have a metal and a non-metal, essentially. So those attract because of their charges. So we have ionic. We have the same here for iron sulfate, which I already named. So it's the same because we have iron as metal, the sulfate polyatomic ion here is a non-metal, so they attract, same as the calcium acetate. And coming down to the iron fluoride, this is the same. We have a positive charge on the iron, negative charge on the fluorine, and so we have a metal and a non-metal, and they attract. And then for nitrous oxide or dinitrogen oxide, dinitrogen monoxide, we're going to call that molecular, and that's because nitrogen and oxygen are nonmetals, and we know that those ionic charges don't even out in an equation like this. They don't attract the same way. So we're going to say that is a molecular bond. So for the second question here, I kind of already had a little reference to this, but so the formulas for calcium acetate and for iron fluoride, and how we did this. So calcium acetate is going to be this equation here. So we have Ca for calcium, and then acetate, we are saying that that's C2H3O2. And that's because we referenced this, and we see that in acetate, this is the ion for an acetate. So we're adding that here, and the reason we have 2 is because calcium has a 2+ charge, and our acetate here has a -1, so we need 2 of these to balance with that. And then it's a little bit kind of the same here for the iron fluoride. We went with Fe, F2, because the iron has a 2+ charge and the fluoride has a negative charge. So we need 1 iron, 2 fluorine to get this, and we named it a fluoride because it is the second name in here. So the second molecule is, ends with an ide. So that's why we went with iron fluoride. So we looked at both the periodic table for their charges, based on their groups up here, and then we referenced common polyatomic ions to find this acetate. So those are those 2. So we've got this and we've got this as our answers here. So we're going to move on to number 3. We have what are the names of the substances represented by the formulas here, and so we went with iron sulfate here because this SO4 that we have here, we find it here on our polyatomic ions. We see here SO4 has a -2 charge, and that's a sulfate. So because we have this, we're calling it sulfate. We have a -2 charge on there, and the reason that we have 2 iron and 3 of these sulfates is because the iron has a+, or actually no, we solved it this way. We went over here We took this, we saw that this has a -6 charge because of the -2 charge on the sulfate ion. So we have -6, and to balance this, we know that we need a iron 3 sulfate because we need 2 irons to balance out that, to give it a +6 charge to balance out this -6 charge. And then down here for the nitrous oxide or dihydrogen monoxide, the reason we named it this is because we have 2 nitrogen atoms, 1 oxygen atom. We have a binary compound, so we use numerical prefixes. So and just to note that the second molecule that's bonded uses the suffix "ide," which I referenced in the previous problem. And so this is its chemical name, and then this is its common name. This is what we know it by. Move on to number 4. So to get the molar mass of this chromium sulfate, we looked up chromium here, right? And we got 51.996 here for grams per mole. So we have one of those, 51.996 for the sulfur. We have 2 molecules of that, so we looked here. We had the sulfur, 32.06. We multiplied that by 2, got our 64.12. Oxygen, we had 8 of those because we have 4 in this ion, and then we're multiplying that by 2 because we have 2 of those ions. So we have 8. So 15.999 times 8, and again, that's because we have 15.999 there. And then we just add them all together, and this is what we get. And the reason we round to 244.11 is because that's what we have up here. On to number 5. Sorry, I'm trying to get through this a little quicker than last time. So I apologize for how this looks. I didn't print it off correctly. So in number 5, we're asking to calculate the mass of calcium acetate present in 0.65 moles. So first we find, no, you didn't need us to talk about this. So we found, anyway, how many grams per mole for all of this. So we added all of those together. So we had 158.17 grams per mole, and we multiplied it by 0.65 because we're using this equation here to find the mass. So we have moles, 0.65 moles times the molar mass, which is 158.17. Then this mole part here cancels out when we do that, so we end up with 102.87 or 8079 grams, and we're rounding that to 102.81 grams in 0.65 moles of this calcium acetate. So then we're going here to number 6. We did that math up here to find the molar mass, and then to find how many liters. We know that 1 mole of gas at standard temperature and pressure is 22.4 liters. So once we find the mole here, we find our mass, and then we use this equation here to find our molar, or how many moles we have. And then we multiply the number of moles by how many liters are in a mole. So that gives us 7.99 liters in a sample. So sorry, I forgot to say we use the 15.7 here because that's how many grams we were given. That's how many we started with. So that's how we find out how many moles we have, because again, we use this equation, we use it up here, and do the same thing, but this time we divide so that we can get the correct number. So anyway, the answer to that is 7.99 liters in 15.7 grams of nitrous oxide. And then here for number 7, we are taking, so we had to figure out how many particles we have here. So we, in Fe, or in iron 2, right? So this is saying that we have 2 iron ions, which we have here, right? So to find that, we're given 5.18 times 10 to the 21st particles. So this one's really simple. We multiply that by that. We get this answer here, 1.036 times 10 to the 22nd iron ions, and we're just gonna round that so that it's a little prettier looking, and we get 1.04 times 10 to the 22nd iron ions in this sample. And then we have 180 grams of iron fluoride, right? So then we need to find how, we have 1 iron in this, so 1 iron is 55.845 grams per mole, and then we find the same thing out for the fluoride, and then we take our grams per mole, we do the same equation we had up here, we get 1.92346 moles, and we round that up to 1.923 moles, and then we take this number and we multiply it by, I always say this wrong, Avogadros, there we go, I don't know, multiply by that number because that's, 1 mole. That's how many atoms are in 1 mole. So we multiply the number of moles that we have by the number of atoms in a mole, and we get 1.1580306 times 10 to the 24th, and we're going to round this to 1.158 times 10 to the 24th iron ions. And when we compare these numbers, yes, we have 1.04 and we have 1.158. Actually, that should probably be rounded more. Anyway, so we have 10 to the 22nd, but here we have 10 to the 24th. So we have 2 extra zeros on the end of this one. So that tells us that our iron fluoride, the second one here, has more iron ions than our iron sulfate. So that's where we have. We stick with that. All right. I think I got through that much faster than last time, but it's still a little bit long. I apologize. Thank you.